Okay, first problem. This is the review for Term 1 DCA. Problem 1 says rewrite 1.25 radians in degree measure. Round to the nearest degree. Now, nearest degree means there's no decimal. So for problem 1, I'm going to take 1.25 radians. I'm going to degrees, so my conversion is 180 degrees divided by pi, and I'm going to round to the nearest degree. So I'm going to take my calculator. It doesn't matter whether I'm in radians or degrees on this because I'm in the computational screen. So I'm going to take 1.25 times 180 divided by pi, and I get 71.62. But it says round to the nearest degree, so this becomes 72 degrees. Well, we use the conversion here, 180 degrees over pi to get to degrees. Multiply 1.25 times 180 and then divide by pi. And that gave me this.
So you multiply 1.25 times 180.
Yes, and then divide by pi. Well, did anyone else get an answer?
You got 45. You probably need to change your stuff to degrees. It doesn't matter.
Well, it shouldn't matter in this one. Now do it again. 1.25 times 180. Get your answer. Well, that's the formula. 180 over pi to convert from radians to degrees.
So you have to round 71.62?
The instructions say round to the nearest degree.
And you got pi from the equation, right?
Yes. Everybody good?
Yes, sir.
Let's look at the second one. Now, the second problem says rewrite 72 as a radian angle in terms of pi. So I'm going to take 72 degrees times pi over 180 degrees. Now, I need pi in there, so I'm going to rewrite this as 72 degrees divided by 180 and then put the pi in the back. So 72 divided by 180 is 0.4. I'm going to convert that to a decimal, to a fraction rather. So this will be 2 pi over 5. Now, these two formulas here that we just used are not on the pre-calculus formula sheet you get with your test. So you need to know those two. Okay? So know this one and know that one.
Okay. So the one for position number 1, you use that for decimals, and the one for number 2, you use it for...
It's not the decimal that does it. If you want to end up in degrees, you use this one, no matter what you start with. If you want radians, you're going to start with this one.
I have a question. Is it going to be a grade?
No.
No?
Okay, we ready for number 3? Ashley, can you see from back there?
For now. I'll just say for now, because I don't have my glasses.
For number 3, we're looking for two coterminal angles, one positive and one negative, for theta equals 100 degrees. So theta equals 100 degrees. For the negative, I'm going to take 100 degrees minus 360 degrees, and that'll give me a negative 260 degrees. For the positive, I'm going to take 100 degrees and add 360 to it to get 460 degrees. So if you want a negative angle, you subtract. If you want a positive, you add.
What did you use 360?
Well, that's a full circle, so you want to come back to where you are. These are coterminal here, so they have to stop in the same place. So you have to go around a full revolution, either up or down.
So if you was to say 200, you would still use 360?
Yes. Okay, number 4. Find the point xy on the unit circle that corresponds to the angle t equals pi over 3. So if you look at your cheat sheet, at pi over 3, x is going to be 1/2, and y will be the square root of 3 over 2. Okay?
That's 1/2?
Yes. But check this on the unit circle. Find pi over 3 or 60 degrees and see what those coordinates are. Okay? Everyone good? Number 5. Find the exact value for the tangent of 510 degrees. Now 510 degrees is bigger than 360, so that's not going to be on my unit circle. I have to find a coterminal angle between 0 and 360. So I'm going to subtract 360 from this, and I'll get the tangent of 510 minus 360 degrees is going to be the tangent of 150 degrees. Now at 150 degrees, can you see? At 150 degrees, the coordinates are going to be square root of 3 over 2 and 1/2, and the x value is negative.
So you looked it up on the circle?
On the unit circle. So find 150 on the unit circle. Okay, is this point correct?
So the exact value means the 4?
Yes.
No, the exact value means it's going to have a radical in it, but it won't be a decimal. So the tangent of 150 degrees is y divided by x, which is 1/2 divided by negative square roots of 3 over 2, which is negative 1 over the square root of 3. And we're going to need to rationalize the denominator. So we'll multiply this by the square root of 3 over the square root of 3, and we get negative square root of 3 over 3. That will be our answer. The rationalization part?
Yeah, like how do you get that?
Well, I'm not sure you really even need.
Wait, is it recording?
Yes.
Okay.
That was your chance to do your dance, and you missed it. Okay. In the old days, back when the world was young and we didn't have calculators, it was considered less desirable to have a radical in the denominator. You wanted them in the numerator. And moving it from the denominator to the numerator was called rationalization. Now to do that, you multiply it by the radical divided by the radical. That's 1, so nothing changed. So the square root of 3 times 1 is just square root of 3. But the square root of 3 times the square root of 3 is just 3. You drop the radicals. So that becomes our answer. Now this is the same as that. If you're taking a multiple choice test and you see one of these two answers and you're not sure if they're equivalent, put both of them in the calculator, write down the decimal, and the decimal equivalent should be the same. And that's the way you check your work. Okay, any questions over that?
But you don't have to do that extra stuff, right?
It depends on what answer's on your answer sheet. Remember, this is multiple choice. If they have the answer like this, you just stop there when you get it. But if they have this there, you may have to go a step further.
But you just have to put it in the calculator.
And compare it, yes. Number 6. We want the exact value of the cotangent of 5 pi over 4. Now, 5 pi over 4 is going to put us in the third quadrant. Now, anytime you've got a number divided by 4 here, the values are going to be the same for x and y. So this is going to be the square root of 2 over 2 square root of 2 over 2. And in the third quadrant, both of these are negative. So the tangent would be y over x, which is negative square root of 2 over 2 divided by negative square root of 2 over 2. That's just 1. And the cotangent is the reciprocal of the tangent. What's the reciprocal of 1? So the cotangent of 5 pi over 4 is still 1.
Okay, so I use tangent.
Well, you could have done cotan, but instead of y over x, you'd have x over y. It'll give you the same answer. But the cotangent is just the reciprocal of the tangent, so I went the long way. But if you recognize that this is really just x over y, you plug it in, you get the same answer.
So cotangent is the reciprocal
Of the tangent, yes.
So every time the denominator is 4, the cotangent will be 1.
It'll either be 1 or negative 1. Tangent 2, so it's going to be 1 or negative 1. Okay, number 7. We're given that theta equals pi over 2. Now the coordinates of pi over 2 are going to be 0 and 1. This is x, and that's y. And we're going to find all 6 trig ratios. The sine of pi over 2 is y. So that means the sine of pi over 2 is going to be 1, because y is 1. The cosine of pi over 2 is going to be the x value, which is 0. The tangent of pi over 2 is y divided by x, which is 1 divided by 0, and this is undefined. Cosecant of pi over 2 is 1 over y, which is 1 over 1, that's just 1. The secant of pi over 2 is 1 over x, which is 1 over 0, and this is undefined. The cotangent of pi over 2 is 1 over the tangent, which is going to be x over y. So this is 0 over 1, which is just 0.
Okay, are you going to
Pay attention, Ashley. Huh?
the 1 over y, 1 over x?
No.
We have to memorize it?
Yeah.
So, Mr. Pretty, why do we do it?
Why do we what?
Why do we do all that work?
Okay. Right now, you guys haven't seen a use for this. But you're going to need this next year. And you guys are so young and naive. I mean, I see you struggling with stuff like this. And you don't know what's in front of you. These are going to be the good old days. But you got to memorize it. But you should know this. SOHCAHTOA? Everyone got SOHCAHTOA? Sure you do. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So just remember SOHCAHTOA. Ashley, pay attention.
I'm listening.
Ashley, come home. Okay, that was number 7. Now, if you don't know this, you need to know it. SOHCAHTOA.
Can you write it down?
Sine, opposite. How do you spell opposite? OPPISITE?
You put double O because
Okay. So how do you spell it?
it's OPPI. SITE.
No, it's OPPOSITE.
Oh no, it's OPPO. SITE.
Where's Google when you need it?
I got it. I know it's going this way.
You got that?
Yes.
Hypotenuse. Spell hypotenuse. HYPO.
H-Y-P-O.
You got it?
Yeah.
Okay. Cosine is adjacent over hypotenuse.
Okay, it says C.
Yeah, C is for cosine.
Cosine what?
Adjacent over hypotenuse.
T is tan.
Yeah.
Opposite.
And T is 10.
Opposite over adjacent. Okay, anybody wants to shoot?
Yeah. You make a copy. Okay.
Okay, what number was that?
That was number.
Oh, it's because I got it right on
Around 8.
mine, but I got confused with the copy side.
Okay, number 8. And number 8 is asking us to find the radian measure of the central angle of a circle of radius 12 feet and an arc length of 64 feet. So I'm looking for this angle here, theta. This radius here, this is not the scale, by the way, is 12 feet. And this arc length is 64 feet, yes. Now this is S, this is R, and theta is equal to S divided by R. So theta is going to be 64 over 12. We can reduce that to 32 over 6. We can further reduce this to 16 over 3 radians. Any questions?
What do you put R A?
That's radian. Now, radians don't have a unit. We just wrote that in when we first started. Ashley, come home.
You're being very nasty.
Okay, so all we're doing is just breaking down the fractions.
Yeah, just reduce it. I'll put this in your calculator, and then it'll convert it to a fraction, and it'll do it automatically.
And will it always be like that?
Will it always be neat like this? No, sometimes they're ugly. I mean, they all work the same way. Number 9. Sine of theta is equal to 3 over 10, and we want to find the cosine of theta. Now, they give you a little clue here. It says you're in quadrant 1. That means everything's going to be a positive number. X and Y both are positive. So the simplest way to do this is draw yourself a triangle. This is theta. Sine is opposite 3 over the hypotenuse, 10, and we're looking for x. So to find that, we're going to use the Pythagorean theorem. X squared plus 3 squared equals 10 squared. So x equals 100 minus 9, take the square root of that, is the square root of 91. Now leave this as a radical. You want exact values. And now we want the cosine of theta. Well, the cosine of theta is the adjacent over
So where did you put the 2 or
the what?
square?
Which?
Yeah, the square.
This one? That one.
The x, like you went straight forward to the end, right?
Yeah, you ought to see some steps, don't you? Okay, let's put some steps in there. Nothing wrong with steps. This just means that x squared is equal to 10 squared minus 3 squared. So this is 100 minus 9, so x squared is equal to 91. Now take the square root of both sides, and x is equal to the principal root of 91. That's how we get the x. Now the cosine of theta is the adjacent divided by the hypotenuse. The adjacent is the square root of 91, hypotenuse is 10. That's your answer.
And that's the answer, or you have to simplify it?
Then you can't simplify that. You can convert it to a decimal, but now it's an approximation if you do that. If they say exact value, you've got to leave that radical in there. Okay, number 10. Number 10 says determine the exact value of each. Now for something like this, I would use my calculator. So I want the arctan of -1. Now you have to make a choice. You can be in radians or degrees here. I'm going to stay in degrees. So I'm going to mode. I'm going to go down to degree. Now remember, arc means tan inverse. So the tan inverse of -1 is -45 degrees. For B, I want the arc cosine of -1/2. So this will be second cosine -0.5, and I get 120 degrees. In C, I'm kind of getting off the table now, is the arc sine of square root of 3/2. Now this should be 60 degrees. So second sine square root of 3 divided by 2 gives me 60 degrees.
Wait, I didn't get it.
You didn't get that? Are you in degrees?
It's because you put it in a fraction.
How am I supposed to do it?
You should put square root of 3 divided by 2.
Yeah.
Did you want to take that test today, or you want to do it later? You can do it during the day, you just can't do it during your class period. Or third period. You can't do it at third period.
I can probably do it with me.
Okay.
That's fine. Bring a note from your teacher. Okay, any other questions over 10? Young Ashley. Are you paying attention? Yes, I did. Are you paying attention back there?
I'm doing my own thing right now. It's good for your class.
You're doing your own thing.
Okay.
Okay, number 11. Given the sine of theta is 5 over 13, find the cotangent of theta. So for number 11, the sine of theta is 5 over 13, and we want the cotan of theta. So I'm going to draw me a triangle. So if this is theta, the sine is going to be 5 over 13, and I need the cotangent. Well, the cotangent is just going to be x over y, which is going to be the adjacent divided by the opposite. So I need to find that adjacent. This is my x. So x squared plus 5 squared equals 13 squared. So x squared is going to be 13 squared is 169 minus 25, which is 144. So x is going to be 12. Now once I see that x is 12, I come back over here, and this is just going to be x 12 divided by the opposite, which is 5. So that's my answer.
This video is going to like the website?
Yes, I'm putting it on YouTube.
Oh.
You gotta be famous.
What happened?
I see you gotta be famous.
Okay.
Okay, that was number 11. Okay, number 12. We want to find all the values where the tan of theta is undefined over the interval of 0 to 4 pi. Now remember, one circle is 0 to 2 pi, so we're going around the circle twice, which means we're going to get 4 answers. So for number 12, we have to analyze this a little bit. The tan of theta is equal to y divided by x. Now, the other day when we were talking about the first commandment of mathematics, one of the things we, you teenagers are just so nosy. You always want to see. You can't see.
Well, you're showing it.
Okay, so when we were talking the other day, we said that you can never divide and get 0. So the only way we get 0 is when the numerator is 0. So that means y has to be 0. So this implies that y equals 0. Now that only occurs twice on the unit circle, at pi over 2 and at 3 pi over 2. But that's just one time around. That's between 0 and 2 pi. We've got to go around again. So when we get to pi over 2, we're going to have pi over 2 plus 2 pi, and then 3 pi over 2 plus 2 pi. Now if I convert that, I'm going to get 2 pi is the same as 4 pi over 2. I'll get 5 pi over 2. And here I'll get 7 pi over 2.
I want to see it again.
You want to see what again?
Paper.
Oh,
Oh, keep going. Keep going. Still got space. Keep going.
so my answer, well, you remember, you're going around twice. This is the first time around. The second time around, these are my numbers. So the answer is going to be 4 numbers. Pi over 2, 3 pi over 2, that's the first time around. The second time around, when I get back to pi over 2, I'm really going to be at 5 pi over 2. And then I'll be at 7 pi over 2 when I get back to 3 pi over 2. And I got that just by adding 2 pi to these. 2 pi plus pi over 2 is going to give me 5 pi over 2. And 2 pi plus 3 pi over 2 gives me 7 pi over 2.
I guess because I was writing, I didn't.
Well, do this in your calculator. Take the pi, this is really 1/2. Put in 1/2 plus 2, and then convert it to a fraction.
You said 1/2
Plus 2.
plus 2?
And convert that to a fraction.
It's 2.5.
Convert that to a fraction. And put the pi back in.
So that's 5 over 2.
Now put pi back in, and you get 5 pi over 2. Now if you do the same thing for this one, you have 3/2 plus 2.
So is 5 over 2 plus 2?
It's, for the second one, it's 5 over 2 plus 2.
Okay, and then you said to convert it?
Yeah, make it a fraction.
That's 9 over 2.
It's not 9 over 2. It's 3 over 2 plus 2.
But you said 5 over 2 plus 2, right?
No, you got to go to the next one here. Go to this one. 3 pi over 2. Now if
Okay,
you,
now I get that, but then like, what you mean how many times you have to go around?
well, in the problem it said go from 0 to 4 pi. One time around the circle is 2 pi. So 4 pi is twice around the circle.
Okay.
6 pi is 3 times around the circle. So if you go around the circle once, you get 2 answers. You go back around it again, you get 2 more answers, which is 4. You do it a third time, you get 2 more answers, which would be 6 answers. Do you get it?
No.
Look at my plate. Okay, I'm going to get a 0 here. Now if I keep going around, I'm going to get a 0 down here. Now I'm going around again, I get here and I got another 0. But whatever number is here, whatever that angle is, when I went around again, I added 2 pi to it. So 1/2 plus 2 is going to give me, what did I get? 5 pi, 5 over 2. When I get back to this one, I've got 3 pi over 2 plus 2 pi, which is 7 pi over 2. And then I'm back to 4 pi. That's where I stop. If I go into 6 pi, I would take this and add 2 pi to it, add another 2 pi down here, and then stop when I get back to 0.
So you just basically add 2 to each of the stops?
Yes. 2 pi, yes.
Okay.
Number 13. We're going to find the missing sides. Okay, now, if you remember some of your trig functions there, the cosine of 60 degrees is 1/2. Cosine is adjacent over hypotenuse. So the adjacent side has to be half of what this is. So that's going to be 5. The cosine of 60 degrees is the square root of, the sine of 60 degrees is the square root of 3 over 2. Okay, you ready? Now you can use the Pythagorean theorem to get this last side here.
Why did you put 5 there?
5?
Yeah.
Because the cosine of 60 degrees is 1/2. This side divided by this side has to be 1/2. So that means this side has to be 5. Okay, you back?
Come back.
Come home. You ready? What are you laughing at? What are you doing, Mr. Brooks? So here we can use the Pythagorean theorem. A squared plus b squared equals c squared. So if I call this y, it means y squared plus 5 squared equals 10 squared. So y squared is going to be 100 minus 25. So y squared equals 75. And y is equal to the square root of 75. Now the square root of 75 can be written as 25 times 3, and the square root of 25 is 5, so this is 5 square roots of 3. So y is 5 times the
That's
square root.
75?
Yes, it is.
Okay, so you said that it has to be the adjacent side is gonna be half of the.
Hypotenuse.
Oh, okay.
Now the others are done the same way.
And how do you find 5 of the square root of 3?
Well, 75 can be written as 3 times 25. So that would be square root of 3 times square root of 25. And what's the square root of 25?
5.
5. So this is 5 times the square root of 3. Now you're going to do these the same way. The only thing is, this is a little tricky. Those two angles are the same. The sum of the angles has to be 180 degrees in a triangle, but this is 90. So these two together have to be 90. 90 plus 90 is 180. So both of these are 45 degrees. And then just do it the same way.
Okay, so for every triangle it has to be half of it?
Mm-mm.
No, I mean for the sides.
That depends on the triangle. But if this one's 45 degrees, that has to be 45 degrees.
No, for the sides, not for the angle.
Well, you got to know the angles before you do the side.
Half of the hypotenuse?
No, that's only if you're doing the cosine of 60 or the sine of 30. That wouldn't apply here.
You're talking about the angles, right?
I'm talking about the side lengths.
Okay.
If this angle is 60 degrees and you want the cosine of that, you've got this side divided by that side.
Okay.
And that has to equal 1/2. So x over 10 equals 1 over 2, which means x has to be 5.
Okay, and now for the next one.
This triangle here? If this is 45 degrees and that's 90, this has to be 45 degrees.
And for the two, I'm talking about the two
Square roots of 2. Okay, now
and that has to be.
if you're looking at that one, the sine of 45 degrees is equal to the square root of 2 over 2. And that's going to be the y value, y, divided by 2 square roots of 2. Cross multiply and divide, and you'll get 2 square roots of 2 square roots of 2 equals 2y divided by 2. And you see that y is equal to the square root of 2 times 2, which is 2. So y has to be 2. And since this is also 45 degrees, this side also has to be 2. Okay? You with me? Say you with me.
I'm trying to get it.
Trying to get it.
Because you got me confused because you said that it has to be half of 10, and then on this one it's down.
That's because the angle's different.
Oh,
The cosine of 60, look at your unit circle and see what the cosine of 60 is.
that's.
It's the x value.
Oh, 1/2.
Yeah. So what's 1/2 of 10?
Oh, 5.
So that's where that came from.
Okay, now
This angle over here is 45 degrees. That's a little different.
45. That's. Oh, theoretical 2.
Mm-hmm. And this is 30. This one will look like this one because that's 60 degrees there. And the cosine of 60 degrees is going to be 1/2. And this is a 6. So this has to be a 12. And this one, I don't know, that doesn't look right. The cosine of 66 is 1/2, so that's that. The sine of 30 is going to be 1/2, so this has to be 6 too. That can't be right. The cosine of 60,
And you always have to use sine, or how do you know you use cosine, sine?
It's either going to be cosine, sine, or tangent. Remember SOHCAHTOA? It depends on what you got to work with. Why is this cosine? Oh, I did that wrong there. It's the right answer there, but this.
Because all of them were right triangles, right?
Yes, it won't work unless it's the right triangle.
So you can basically use the same thing,
Okay, what do you mean by the same thing?
like the same sign, like, I don't know.
Well, you either have to use sine, cosine, or tangent, depending on what you've got and what you're looking for. In this case here, if that's a 30-degree angle, this has to be a 60. The cosine of a 60-degree angle is going to be 1/2. So this has to be 6.
That's what I'm confused on, because you say cosine and then you use sine over there.
Okay, I'm a little confused now.
Okay. So you use sine for this like huge.
Are we talking about this one?
No. Okay.
This one?
Yeah, so you use sine for the second one, and then for the third one you're using cosine.
Well, I want this side. Well, I may have gone too fast on the third one. Let's do the third one over again. So for this one, I know this side over here is 6. And this is
Afternoon,
12.
staff. Any football students that are in tutorials must now report to football. Any football students in tutorials, please make your way to football practice. Thank you.
Is that you, young man?
Yes, sir.
You guys going to win this week?
Yes, sir.
It's homecoming.
That's the only loss we take this year.
Okay. You still have to play Davis.
Yes, sir. They're not.
I saw them on television the other night. They looked pretty good to me. They whipped up on spring. Okay. Let's go back to this one. I've got this side over here. Okay? So this angle here has to be 60 degrees. This one over here, if I use the cosine of 60 degrees, let's not do this yet. The sine of 60 degrees, that's the sine of this angle here, is going to be the square root of 3 over 2. So that's going to be 6 over something, hypotenuse. So square root of 3 times h equals 12. So h is 12 divided by the square root of 3. So this is 12 over the square root of 3. Now I need this side here. The cosine of 60 degrees is equal to 1/2. So that's going to be the adjacent side x divided by the hypotenuse, 12 square roots of 3. If I multiply this over, I get 6 square roots of 3 equals x. 12 divided by 2 is going to be 6, and I got the square root of 3 there. So this is going to be 6 square roots of 3. And that can't be the scale there.
Okay, so now that I'm looking at this, cosine equals x and sine equals y,
Yes.
because that's what I was confused on. That's why I was like, when you say sine, when you say cosine, but I guess it's because of the x and the y.
Well, yeah, it's what you've got there. If this is 30 degrees, the cosine, I'm still not sure I did that right. Let's look at it one more time here. Number 13. I'm going to recreate the triangle. This is 30 degrees. That makes this 60 degrees. I know this is 6 over here, and I need to find these other 3 sides. Well, the first thing I know is that the cosine of 30 degrees is equal to the adjacent 6 divided by the hypotenuse.
We can see.
Okay? So the cosine of 30 degrees is going to be the square root of 3 over 2 equals 6 times h. So h is going to be 6 divided by the square root of 3 over 2, which is 6 times 2 divided by the square root of 3, which is 12 over the square root of 3. So this is 12 divided by the square root of 3. Okay. Now the cosine of 60 degrees equals 1/2, and that's going to be x divided by the hypotenuse, 12 over the square root of 3. So this becomes 12 square root of 3 over 2 equals x. So this is going to be 6 square roots of 3 equals x. So x equals 6 square root of 3. And that is certainly not the scale there.
Okay, I get it, but then I don't get it because why do you use cosine?
Because I was given this side here. So if this is my angle, this is my adjacent side, and I need the hypotenuse, so I have to use cosine.
Okay.
And down here, the cosine is 1/2, so this divided by that is 1/2. Yeah, cosine of 60 is 1/2. 6 over h. Yeah. Okay, that's not on your test anyway. Now, do we need to do number 14?
It's the same, right?
It'll be pretty much the same. Only now we've got cosine adjacent over the hypotenuse. Cosine of 27 degrees equals 700 over x. So x is going to be 700 divided by the cosine of 27 degrees. Put that in your calculator and get your answer. Ashley. If you what? You have to give it to the nurse, and then she has to keep it for you. Then if you need it, you just get a permit to go to the nurse, and they give it to you.
What can we bring it in my class?
Well, nobody sees you with it, nothing. But if they search your bag, go home and do the metal detector and find it, they're going to say something, probably take it from you. Now, if you got something like an aspirin, I mean, that's probably nothing's going to
So I
happen.
can bring like Tylenol? 70?
I can't tell you whether you can or not. The answer is probably no officially, but you know, if you got a Tylenol pill you stuck in your pocket or something, who's going to look for it?
We have to put it in radians or degrees on the calculator.
For this one?
For the motor. No, for the top one.
Up here?
Yeah,
No, that's in degrees.
That's in degrees?
Yeah.
Wait, but you're looking for a size.
Yeah, but you're dividing by a trig function, and it's in degrees.
Oh, okay.
Okay, for number 16, this is the one where we lost some of our work. This side is 4.
Is it right for me to get 785, 163?
For this one?
Yeah.
I guess. I don't really know. I didn't do it, but
And we have
it
to
doesn't
round
sound
it.
unreasonable. Well, I would go to 2 decimal places unless I was told differently.
Okay.
785.6.
Yeah, 63.
Yeah. Okay. Now for number 16, you want the cosine of A plus the sine of A. Well, the cosine of A is just going to be the adjacent over the hypotenuse, 3 over 5, and the sine of A is the opposite over the hypotenuse. You've got a common denominator, so you add the numerators, and you get 7 over 5. Yeah, cool. Okay, now number 17 is akin to what we were doing earlier today on the warm-up. So we've got 4 sine of 4x plus 4. The amplitude is going to be 1. The period is going to be 2 pi divided by 4, which is pi over 2. And the range is going to start at, it's going to start at -1 and go to 1, but then we're adding 4 to it, so the range is going to go from negative.
Okay, hold on. You said A equals 1.
Yeah, what number's in front of sine? What's in front of sine?
Nothing.
Well, that nothing has a name. What do we call that nothing?
I guess 1.
1, yes. There's an implied 1 here because 1 is a multiplicative identity.
Okay.
So if there's nothing there, it's 1. So the amplitude is 1.
The period?
Is going to be 2 pi divided by whatever this number is.
2 pi divided by 4?
4, yes.
And if you simplify it,
Pi over 2.
okay.
Now this goes back to sinusoidals. Remember what b is? 2 pi divided by the period. So the period is 2 pi divided by b, and that 4 is b. So we get this. Now as
For the range what?
for the range, if you were to graph this, it would go from -1 to +1.
Okay.
But now you're going to add 4 to each of those. So 4 minus 1 is going to be a +3. And 4 plus 1 is 5.
Why is that an add?
Well, because you're adding 4 up here.
Oh. So what's that, the period?
No. That's going to be, this right here is going to be the range. The period is this.
So the one on the top is whatever you see on the graph.
Okay, you're going to have to be a little bit more specific than that.
Yeah, because you said if we graph the
Yeah.
y equals all that, then the range will be -1.
Well, if you graph it without the 4 in there, it'll be -1 to 1. When you put the 4 in, you're going to shift it up 4 units. So when you move -1 up 4 units, you're going to get a +3. When you move 1 up 4 units, you're going to get 5. But the difference between these two will always be the same. 1 minus -1 is going to be a +2. 5 minus 3 is a +2. Got
You
it?
can even graph that on the calculator, right? The whole thing, you can still get the same thing?
Yes. And now we have to pick the answers. The amplitude is not 0, so A can't be true. The domain is all real numbers, so that can't be true. Now, the next one, the range is 3 to 5, that's true. The period is 4, that's not true. So the correct answer is D, only 3 is true.
Only 3?
Only 3. Why is that?
Because the range is true.
Look at what's true here. The amplitude is 0 is not true, so 1 is gone. Wherever you got a 1, X it out. The domain is -4 to 4. That's not true. It's all real numbers.
It doesn't matter whatever you use. It's always going to be all real numbers?
For the domain, yes.
Okay.
There's no you can plug any number you want in for X, and you're going to get a number out of it. The range is 3 to 5. That's true, so 3 is true. The period we know is pi over 2, so this one can't be true. The only one true here is number 3. So look down here for number 3 by itself, and that's going to be D.
D.
Yes. You good? You okay? Okay, let's keep going. Determine the graph of 1/3 cosine. Well, 1/3 means that's the amplitude. So the only possibility is, can't be this one because that's 3. This is 3. It's got to be either C or D. Now the value of the cosine is going to be 1 at 0. This one down here is going to be a negative 1/3. This is a positive 1/3.
Going so fast.
That's because you're trying to write down everything. Just pay attention.
Okay.
And then write it down after we finish. What's my amplitude here?
1/3.
Is that 1/3?
No.
That's wrong. What about this one?
No.
So it's got to be one of these.
Uh-huh.
Now, at 0, what's the cosine?
Let's see what's the cosine.
Look at your unit circle.
That's pi over 2.
No, it's 0. What's the cosine?
At 0?
Yeah.
2 pi. 1?
1. The x value is 1. And what's 1 times 1/3?
1/3.
So we're looking for a positive 1/3. We've got it here, but what do we have down here?
Negative.
So it can't be this one. So the answer has to be that one.
Oh.
Now, number 19 is what we were doing on the warm-up today. The amplitude is what?
Six.
Mm-hmm. And what's the period?
The period. There's no.
Oh, there's a period. Rewrite it this way. 6 sine of 2 pi x minus 0.5 pi plus 11. So this is your amplitude. Your range is 2 pi divided by 2 pi, which is 1. I'm sorry, that's going to be your period.
Oh, yeah.
So this is your period. And we're looking for the phase shift. That's C. The phase shift is going to be 0.5 pi. And the range for this would normally go from negative 6 to positive 6, but we're adding 11 to it. So add 11 here and 11 here, and we get 5 to 17.
Okay, so you put 0.5. That's pi?
Yeah, that's a pi. How did I get that?
Because you multiply 2 times.
Yes.
2 pi is 0.25.
Yes.
And then for the range.
Now, before you leave that, now let's go back and think about sinusoidals. This 2 pi was my B. This was my C. Remember that?
Mhm. Okay, now for the order here.
Down here, the range.
Uh-huh.
Well, the range is going to be plus or minus the amplitude to start with. So minus 6 to plus 6. But in the back here, I'm adding 11 to it. So when I add 11 to negative 6, I get a positive 5. 11 to a positive 6, I get a positive 17.
Okay, so first, whatever number that's the amplitude, you're going to put negative 6 and 6.
Yes.
And then you're going to add whatever number is part of the.
Add D to it.
Okay.
Now D is going to be your vertical shift.
So it's going to be negative. It's going to be 516.
517.
Oh, yes. And that's the range?
Yes, it is.
That's D? No.
Well, 19 is just probably going to be a bubble in, so. Now for number 20, we're missing something. Did you put that on your paper? So for this one, it's 5 cosine of x over 13 plus pi over 5. Now let's go through and find the amplitude. The amplitude is going to be 5. See why? Amplitude is 5. The period is going to be 2 pi divided by 1 over 13, which is 2 pi times 13 over 1, which is 26 pi. So we're looking for an amplitude of 5 and a period of 26 pi. So that's going to be B. Now for number 21, use your calculator on this. Yeah, and see which one gives you the same graph. That'll be your answer. The two with the same graph is the answer.
With the same graph.
Well, one graph will be on top of the other. One and two? That sounds right. Well, it couldn't be 1 and 3. Those are odd. So the only answer could be 1 and 2 or 2 and 3. Now 22, we've done enough of those. I don't think we need to do it. We got videos on Ferris wheels too. So I'm going to skip that one. Okay, now this one you can put in your calculator and match it up. Now focus on what happens here at the y-axis. This is what you want to see here.
So that was going to be 1 and 3? For number 21 was going to be 1 and 3?
Well, I'm not sure what the answer was.
It was
1 and 2, I think.
1 and
yeah, it was 8.
How?
Because, alright, so you can put it in the calculator, right? Just like how it is. And then you'll see that cosine makes the line. And then when you go to number 2, plug that in, it goes over it. And then when you plug in number 3 just stays by itself.
Yeah, I'm sorry.
This is good, yes.
Okay, so the red one.
You stay up to 2 and 3, you can't hang.
And then you put this one. You see? There's not 1 and 2, 1 and 2.
No, it won't be 1 and 3. No, it won't. It either has to be 1 and 2 or 1 and 3.
1 and 3?
I don't think so.
You
You
can check.
divide it and put it in practice.
No, 1 and 3 might work, yeah. No.
You can check if you want.
Yeah, we'll have to check that because I don't think that's
Oh, it
true.
is 1 and 3.
It's 1 and 3.
Okay, this is moving to the left, pi over 2.
It just covered.
Let's go from 0 to 2 pi would be about 8. And y would be negative 1 to 1. That's not right. Yeah. It's not going to be 1 and 3. It's got to be 1 and 2.
How you know 1 and 2?
I'm going to show you.
Because you just covered the blue. Like
Okay.
1 and 3. Oh, it is 1 and 3.
No, it isn't 1 and 3.
Oh, it is 1.
Are you in radians or degrees?
I just put it. I just restarted it.
Okay, let's put it in radians. Because we're in degrees right now. Okay, that's 1. That's the
Okay,
cosine.
so that's different, right?
Yeah, I think it would have been in degrees too. Now this is 2 coming up, so you're going to take the sine, you see it?
So it has to be worked differently then.
It's got to be in radians.
Okay.
Okay. So
It's gotta be 1 and 2.
let's before the test we reset it and it'll be in radians or in degrees.
If you reset, you're going to go to radians.
Okay.
Mm.
Okay, are we good on number 21?
Yes, sir. 1, 2.
Okay, now, graph number, 22 we've kind of done. We've kind of beat that sinusoidal. So do number 23. Now set your window to match this window here. So you want your x-axis to go from negative 4 pi to positive 4 pi. So we're going to go to the window. X is going to be negative 4 pi to a positive 4 pi, and y is going to go from negative 4 to a positive 4.
Negative 12.
It does it automatically.
This is 4 pi.
You put 4 pi right there?
Yeah.
It does it changes it automatically. Because remember you're in radians.
And secant is 1 over the cosine. So we want 1 divided by the cosine of x over 2.
It's not sick.
Well, you can't put secant in there. It's got to be 1 over the cosine.
X over 2.
Yeah, 1/2 x is x over 2. I mean, it's 1 divided by the cosine of x divided by 2. Something's wrong here.
Oh, you gotta reset your calculator. The 2 months comes up.
What is yours? Yeah, that's what it should look like. Okay, now match up your graph and look at the y-axis.
How do you know it's a code?
Secant is 1 over the cosine.
Oh, secant is 1 over the cosine?
Yeah, you got to know those. Yeah, I was in degrees too. That's why mine was doing that. So now if I graph it, I should get what you got.
It should be D, right?
Should be B, I'm thinking.
B?
Yeah.
Oh yeah, actually. It just doesn't something.
So you get something like this, but make sure you're in radians.
What's the equation again?
It's,
It's right here. Top.
but you can't put that in, so you have to put it in terms of cosines.
Oh, I was missing
So, what if it was CSC?
Then it would be 1 over sine.
Can you graph it again so I can see, please?
So that's gonna be B.
Yes.
Oh, and if it was COT, it would be 10.
Yeah, but tan wouldn't look like that. Cotangent would be a decreasing graph like this.
It just goes to 40.
Now for number 24, just put them in the calculator and see which two graphs look like that. And same thing with 25.
Arc means it's going to be
Inverse. Yeah.
okay, so this one says COT. So then I would do 1.
Which one?
C, it says COT.
So you're going to put in tan of x and then 1 over tan of x. Cotangent is 1 over tan.
What does cotangent mean?
Cotangent is 1 over the tangent. Which one are you looking at? C?
Yeah.
Yeah.
It's gonna be 1 over the 10.
It is, but that's an inverse function there, so it won't be that one. It's going to have to be the original function and some arc of that function. And I think we can eliminate C and D, so it's either going to be A and B. I don't know, maybe we can't eliminate D.
It's not A.
My mind goes like that.
Where do they get those big jumpsuits for girls that big? Those little baby
They're
suits?
called onesies.